Hello, folks. I wanted to go ahead and make a video where we give some options and some feedback on some practice with Psych Experiments assignment here. Again, the due date on that has passed, but it gets from Unit 0, so as long as you get it submitted, you'll still get full credit. And I noticed a lot of people kind of struggling with this a little bit or not being quite specific enough with some things. This is one that feel free to be creative. It works a lot better if you are creative. But just make sure that you are hitting the key points for each of these columns at the top. So in our first example, it says if the owner of a small business lowers the room temperature in the offices, then the productivity of her employees will improve. Well, first of all, we need an operational definition of the independent variable. The independent variable here is the temperature in the rooms, all right? Specifically lowering the temperature. But if you just say temperature or lowering the temperature, that is not enough. You need to clearly define what that means. And the key for that, the whole key of operational definitions in general, is allowing for other researchers to replicate your work. And if they can be replicated and they find similar results, then you are now, that adds validity to your research. So very important there. We want all research to be replicable and generalizable. And that is going to deal with making sure that we have an appropriate sample of our population, both in the experiment, in our experimental group, or not experimental group, in our sample of the population, as well as in each these experimental and control groups. So if we say just temperature or lowering the temperature is not enough, being specific, lowering the temperature 5 degrees Fahrenheit from the normal of 72 degrees Fahrenheit to the new 67 degrees Fahrenheit. That is more clear. Now, anybody, even if you're in the metric system, you're using degrees Celsius, well, you can convert 72 degrees Fahrenheit over to whatever that is in Celsius. So they can make that adjustment. Next up here, an operational definition of the dependent variable. Obviously, productivity of the workers. They mentioned that. That is what the boss is assuming will be dependent based on the independent variable, the change of room temperature. Again, you could say something along the lines of amount of tasks they complete in one day, but again, we want to kind of define what task is. So one of the things I think is handy here is, since they don't specify what kind of office this is, just create a job if they don't specify one. Create something that's an example, and you can come up with the operational definition based on your example. So on a normal day, the workers complete 9 TPS reports. So that's at 72 degrees Fahrenheit. We will see how many TPS reports the experimental and control groups can complete. So the experimental group will be the ones at 67 degrees, the control will stay at 72. And again, this is a semi-fictional thing. I stole this from a movie from the 90s called Office Space. Next one here, the experimental group is workers in the offices that have lower temperatures, and control group is workers in offices where the temperature has not changed. I actually have 2 different examples here. So in this top set here and here, the idea is that the office is large enough, or that the company is large enough that maybe each worker has their own office, or that they're divided up into 2, 3, 4 kind of areas. So we could lower the temperature in one area and then close the door, and in the rest of the areas it'd be at the normal temperature. That is an option here. In that case, a possible confounding variable for that scenario is, again, it did say it was a small business. So you might only have 2 or 3 workers in each group. Well, if one of those workers had a bad, really tragic weekend, their pet passed away or a loved one passed away, and a human, whatever it may be, they're probably not real focused. And they might be in the experimental group, and they might only get 2 TPS reports done. And all of a sudden, the rest of the group got 12 each. They got 2, so that's 12 plus 2 is 26. Well, the other group normally gets 9. Well, if that's 3 people times 9, that's 27. They still end up coming up short. So they might think that things did not go well, but in reality, it was a confounding or third variable, the pet or the loved one passing away. And that could happen on the other side too. Maybe in the control group, one of those people, their pet passed away, and it makes it seem like even though both groups on average did the same work, that one person, not average, all workers that were in a normal state of mind got the same amount of work done. that one person in the control group that was not in the lower temperature might have gotten very little work done, and that makes it seem like the experimental group was a lot more productive than the control group, when it's really just that confounding variable. The other option I had here is maybe they can't change the temperature. Maybe it's got to be the same temperature throughout the office. They can change it, but it's going to be the same everywhere. You could do, workers for Monday and then workers for Tuesday. I'm trying to compensate for the confounding variable of days being closer or further from the weekend by saying workers on Monday and Wednesday as the experimental groups. We'll have 70 or 67 degrees on these days and 72 degrees on these days. That's one option. You could go, 1 week and then the next week. That could be an option as well. There's just a lot of things can change from 1 week to the next. Again, it could be stuff like this, or it could be, on Monday, workers are recovering from an active weekend, whatever that may be. But they went out and ran a marathon, and they're exhausted on Monday. Or maybe on Thursday, they are just thinking about the flight they're taking to Orlando to go see Disney World for the 3-day weekend or something like that. They're not really focused because they're thinking about all the preparation they got to take for the trip. So those are all examples you could have for situation number one. Situation two, if college swimmers drink an energy drink an hour before practice, then their practice times will improve. Well, again, if we're going to have an independent variable here, the energy drink is the independent variable, but what energy drink? Is it a Red Bull? Is it a Monster? Is it Celsius? There's a variety of them. So we'll just say Red Bull. So even then, is it the regular one? Is it sugar-free? Is it a flavor? We'll just, I guess, keep it simple. I think I got one on my desk here. Sugar-free Red Bull. And what size? An 8.4 ounce. 8.4 ounce sugar-free Red Bull. An hour before practice. So that was clear there. Okay. Now, as far as practice times, the dependent variable will be our practice times. So let's say here, again, you have different swimmers that have swum different races. You might have people swimming a 50-meter, 100-meter, backstroke, freestyle, whatever it may be. But we're looking for a statistically significant decrease in swimmer, I should probably spell it right, lap times. And again, that's still not real informative. The statistically significant kind of helps me out a little bit here. If you remember, we talked about that, making sure we do a t-test to get a p-value, and our p-value would need to be 0.005 or less, 5% or less, to know that we have 95% confidence that it is, in fact, due to our independent variable the changes are. So I'm kind of using concept application here to make my answer a little bit simpler. All right, the experimental group would be swimmers that drink the 8.4 ounce sugar-free Red Bull, copy, paste, 1 hour before practice, and then this would be the rest of the team. Now, to just do it this way, well, how many swimmers? Is that 2 or 3 people? And this is 12. We would like to have it be both representative. Now, this is college swimmers, so are we talking about some of these kids might be, freshmen right out of high school that haven't been serious, athletes. Maybe they were just talented swimmers, but they haven't, swum consistently at this level a lot. Or some of these people might be fifth-year seniors or sixth year. They had a COVID year and they got an extra year of college, and they're 23 years old. So we want to take some of those variables into account and make sure that our populations are both representative of the overall makeup of the team. That can be difficult at times. You might only have 10, 11 people in your college swim team. So if you only have one sixth-year senior and you have 4 juniors, 3 sophomores, and 4 freshmen, whatever that works out to, it might be hard to have a representative sample, but that's you want to do the best you can. And then finally, a confounding variable. Again, kind of like this one up here, an active weekend. They're in college. Maybe it just so happens that of the people you select to be in your control group, that maybe, half of them went to a party last night and they are not going to swim real well today. That's going to make things look different. Now, I suppose you could also get all the swimmers the energy drink on one day, and use that time and compare it to their baseline times before. But even then, let's say all swimmers on the team. All right. So we did all swimmers on the team, and we use this as their times from the previous practice or swim meet. All right, that might be a little bit simpler. So one confounding variable here is if you're talking about the times from the previous practice, well, we could have the issue of not experiment or bias, but the placebo, not a placebo effect. I got to think of the term for it, but the bias where people feel like just knowing that they have the medicine that they should do better. And I definitely need to look that up, but I don't have it in front of me right now. So bias can certainly play a role, that they might work harder in the pool, knowing that their time should improve. They're going to work harder. Another option might be if we're comparing it to their previous swim meet. Well, adrenaline plays a big role there. People are going to swim faster in a swim meet or run faster at a track meet if they are racing against somebody and they're competing compared to what they do in practice. That's just human nature. So a confounding variable here could be the role of adrenaline in the meet times compared to lower levels at practice. There's an option there. Moving on, high school senior substitute social time for time spent on the internet, then levels of depression will decrease. High school senior substitute social time. I believe they mean they're going to add in social time and reduce time spent on the internet. I think that's what they're trying to say. Okay? So here we'll say percentage of time of free time, which means not in class, working, or sleeping, so we'll make that plural, percentages of time spent with friends versus on internet or a device, like screen time. And obviously, like the spent with friends, that would be spent with friends, not necessarily like gaming or something, or just hanging out in the room, but everybody's doing their own thing on their phone, actually spending time with the friends. That's an option there. So again, for an dependent variable, well, levels of depression. So maybe have a self-reported scale of 1 to 5, 1 to 10, 1 to whatever you want, before and after the time change. So let me go back to our independent variable, where, before the students were spending, say, of that free time, they were spending 30% with friends and 70 on the internet, 70% internet. And then the experimental group will get, I don't know, let's go 50-50. Okay, so self-report. Again, how do you feel right now? What is your level of depression? 1 being not at all depressed, 5 being super depressed. And then we go through this experiment 50% time now and self-report again, see what we get. All right, so obviously our experimental group will be, let's say, students from ABC High School that take part in 50% with friends campaign. Now, in this case here, they might be, let's say, bowling, putt-putt golf, and going to summer league games at McNair Field. Okay? That's not how you spell putt-putt, I guess. Is it P-U-T-T? There we go. All right, and then everybody else. Students also from ABC High School that continue with their normal routines. All right. A possible confounding variable is a million, you know. Let's see here. What if prom's going on and your boyfriend or girlfriend decided to dump you right beforehand and take your best friend instead? Well, that sure would be a confounding variable. Again, a family member passed away, your dog passed away, or maybe you get a great new job and it paying you twice as much as your old job. You're feeling really good about that. So again, we've already mentioned loss of loved ones. So let's say students could get accepted to their primary college choice. They're going to feel real good about that, and that's going to obviously decrease their level of depression, regardless of which group they're in. Next on, prison warden paints the walls of his prison pink, then the behavior of the prisoners will improve. Again, this would be cells with pink walls. Now again, I think you go through and define which pink you are. I'm going to say he is using Pepto-Bismol pink. And that's how you spell that. All right, so that's our, again, double checking independent variable. I'm going to go ahead and copy this because it's getting annoying. And paste it. Row below. Paste right there. Awesome. I don't have to scroll so far. All right, so we have cells with pink walls using Pepto-Bismol pink. The dependent variable. Now, the behavior of the prisoners. That's not enough. All right, we have to be able to measure that so we can replicate this other thing, the experiment. So we'll say frequency of, we'll just say lockdowns. That's a possibility. Or frequency of causing lockdowns. Who's causing them? Is it prisoners from Pepto-Bismol cells or the normal cells? The experimental group will be prisoners in the Pepto-Bismol pink cells. Control group, the rest of the prisoners. Confounding variable, maybe they had to do a cell change. Maybe they had to move cells in order to be in the pink cells. That lack of being in your normal setting can certainly throw you off. Let's see what else. Confounding variable. Again, you could get news of something bad happening. Maybe your parole was denied. That could certainly, again, the prisoners in the regular cells, you might have 2 or 3 of them might have their parole denied, and they're upset about that, and that could make it seem like their behavior's worse, and then relatively the Pepto-Bismol prisoners' behavior is better. All kinds of things. Again, the same thing could happen for the Pepto-Bismol prisoners. Their parole could get denied, which would decrease the effect of that independent variable, or it could get approved, and they say, find out they only have 6 months left instead of 6 years, and they can be very happy about that. If softball players eat Cheerios before a game, then the number of runs scored will increase. Well, that would be not just eating Cheerios, but eating, we'll say, 4 ounces of Cheerios. And we'll say they eat those 4 hours before the game. You don't want to eat right before the game. That wouldn't be great. It'd be 3 hours before, but we'll go 4. Eating 4 ounces of Cheerios. We'll say dry Cheerios. You're going to just eat the cereal, no milk. That will help us reduce, people that have lactose intolerance or something like that. So just eating the Cheerios. An operational definition of independent variable, well, the number of runs, that's pretty straightforward. We'll say a statistically okay. And the experimental group would be the players that I feel like you have to do the whole team here, because if you just do a few players and not others, well, scoring runs in softball and baseball is definitely a team thing. Unless you're talking about home runs, what can be done by one person, whether or not someone's on second or third base is a big difference in whether a single scores runs or not. So I think it needs to be the whole team. The whole team on the day of a whole team eats Cheerios every other game. Control group would be the games that they do not eat Cheerios. And you're probably already seeing some confounding variables here. Take a moment to think about some of the confounding variables that I've inadvertently introduced here. All right, we say in every other game. Well, they're not playing the same opponent every week. One week they might play the worst team in the league, and the next week they might play the best team in the league. So, quality of opponents. Now, one of the things I know in North Carolina we're starting to do is play the same team back-to-back. So you might play Brevard on Tuesday and Thursday this week, one in here and one at their place. The next week we might play Hendersonville, one here and one at their place, and so on and so forth. But again, home field advantage is a thing. You'll learn later on. It's not a huge thing necessarily. It depends on the sport. But a home field advantage, quality of pitcher that you face. Put that in there with the quality of opponent. All right. Again, how's school going? Are they do they stay up really late the night before doing homework? Stay up late doing homework. Or are we talking about games early in the season where they're not that used to it? They just came out of basketball season. They're still getting their swing back. They're getting used to seeing pitches, things like that. Or games later in the season where they're really humming. They've gotten a lot of practice in. A variety of things you could pick out for confounding variables there, and probably some that I haven't mentioned, I'm sure. If a factory foreman, let's see here, post this in down below, insert row below, and paste. All right, factory foreman improves the lighting in a factory, then the number of accidents will decrease. That sure makes a lot of sense. So, I mentioned quality of lighting would be our independent variable, but again, not specific enough. So, talking about the number of lumens, most likely what we say. Not just the amount of light emitted, but also the placement of those lights. It wouldn't really matter how bright a light is. If it's sitting behind a big piece of machinery, there's a shadow. You're going to have a dark area behind it. So, let's say, normally, let's say here. Be measured by a light meter. So we could have a light meter that measures the amount of light at certain locations within the factory at all, I would suppose, work areas. So we're going to increase wattage, like that, lumens of lights used, and number of light fixtures until every workstation has 50% more light as measured with a, making this up, let's see here, light meter spectrometer 2000. Okay, so again, feel free to make stuff up. Well, at least within reason. Or how about I just say measure with a portable light meter. We don't want to confuse your, did I spell that wrong? Meter? It looks good. We don't want to throw off the AP readers. All right, so that sounds better. We're going to increase the lumen, and I'm sure that's not exactly phrased right, the lumen power of lights used. Again, that's how much light it puts out. And the number of light fixtures in the factory until every workstation has 50% more light as measured with a portable light. I knew it. Oh, gosh, silly. All right, an operation definition, dependent variable. Well, it's the number of accidents. So we'll say number of accidents per month. All right, so factory with lighting upgrade. Previous records of factory accidents over the previous, I said that twice, 3 years. How about this? Average number of factory accidents per month over the previous 3 years. Okay. Again, confounding variables. We mentioned over the last 3 years. Maybe this is a new factory foreman. Maybe this is part of an overall emphasis that he has had on safety, or she has had on safety. So changes in management / focus on safety. Here recently, maybe the last person got fired because the last 3 years they had a ridiculous amount of accidents. So they brought this guy in, and he's had a variety of things, initiatives that they've had to increase safety over the last couple of months. Well, we're looking at the last 3 years, a little bit different numbers there. Let's see, what else? As far as the light is concerned, I don't know, maybe half of the workers, or this is a really silly example. What if it is an assembly line set up for blind workers? It's kind of silly, but blind people can work. They can assemble things, and they really wouldn't need light. So the productivity would not presumably change at all if it was a place that designed for blind people. I don't think that's offensive. I hope it's not. All right, next one here. Last one. All right. If a high school history teacher wears a bright red tie to class, then the attention spans of his students will improve. So that would be the wearing of the tie, bright red tie, that is. The attention spans. So I would say the length of time that students' pupils, again from their eyes, are focused on the teacher before drifting away. So let's do average and this could be as measured by a pupil detecting camera with pupil detecting software. That's better. Which, believe it or not, is a real thing. I had a friend of mine in college. Well, I didn't really like him that much. I knew a guy in college that was an engineering student, and he did some kind of research. I know he was in something to do with safety of ladders, but he also mentioned they had a technology where they could see what you were looking at. So you were looking at this screen, and the screen's looking back at you, and it can tell what your pupils are looking at. So, again, we set up a camera at the front of the classroom, and it can detect exactly who's looking at the teacher and for how long. Maybe the camera would be pinned to the guy's shirt. I don't know. And with technology today, it could probably be pretty small. So that would be the idea. So now again, the experimental group will be students in class on red tie days and students in class on other days. Again, the confounding variable, well, does this guy always wear ties, or are ties a new thing? Maybe he wears Hawaiian shirts a weirdly high percentage of the time. And then all of a sudden he's wearing a tie that's a little bit different there. Maybe he always wears ties, but a red tie might actually be a very tame tie for him. Maybe he sometimes wears like tie-dye ties or bright pink or Pepto-Bismol colored ties. Maybe his ties might have sports mascots on there that he particularly likes, and maybe he is not from the community. So maybe everybody there is a Carolina Panthers fan and a Atlanta Braves fan, and he's bringing in ties for the, I don't know, Tampa Bay Buccaneers and Tampa Bay Rays, teams that nobody likes. So they're annoyed by his ties, and they annoy, like that annoyance of the ties has them kind of drawn to him more. So the variety of things there. Again, you can kind of get silly with it if you want, but just make sure it's something along those lines. And again, the student's attention span, we're talking about totally different days. Lots of things can happen. Maybe he's wearing the tie in the morning, but not in the afternoon. Well, the kids in the morning students in the morning are generally more alert than students in the afternoon. Fourth periods are kind of rough for that, in fact. Or first period versus second period. First period, you might have kids still half asleep. So a variety of things. So is wearing a tie unique? Therefore, more noticeable? Does he always? Does he? There we go. All right, so there you go. There's a variety of answers we have. Wasn't intending to type all that out, but there you go. Variety of answers for all of these things. And again, hopefully you see you can kind of add your headings in there if you'd like to make things a little simpler for you. If you have any questions on this, please let me know. I want to make sure we get this stuff down. All these operational definitions, independent variables, dependent variables, experimental groups, control groups, confounding variables, all very important things that you will see a lot this semester, especially on the free response questions for our test and for our AP exam. May 16th, 2025, coming right up. Have a great afternoon. Bye. Oops.